Next, let's add the windshield wiper controllers. Let's look at the wiper model. Here we can see it already has a certain angle where it connects to the car body. This is the same problem we encountered with the steering wheel. So we need to do the same operation here. Create some locators and then use an aim constraint to redefine the coordinate system's orientation. This is the only way to make the controller rotate the wiper along the predetermined angle. So let's do this together. We'll select the connecting part, then isolate it. The center of rotation is actually the center position of this edge loop at the end. Because the model behind it isn't closed, there isn't a point we can snap to directly. Here, we'll use the method we used to find the tire's center point. Select this edge loop, then find Convert in Modify, Polygon Edges to Curve. Then in Modify, find Center Pivot. This way, we've found this center point. Then create a locator and snap it over. This way, we found the center point position of the left wiper. Let's rename it. Then delete the curve we just created. Then we need to duplicate two locators and use an aim constraint to fix its orientation problem. We've already done this when rigging the steering wheel controller. Let's do it again here. Its orientation should definitely point to the center point of this face at the top. So let's duplicate a locator, snap it to this position, and the up reference position will be the corresponding point above it. This way, we've determined the positions for all three locators. Copy the name of the up reference object, then use the locator at the top to apply an aim constraint to the locator at the center point. The up reference object here is the name we just copied. Click Apply. This way, we've defined its orientation. Then delete the aim constraint. Also delete the two locators we just duplicated. Next, let's duplicate one. This is the locator for the right side. We'll do the same operation for the right side. We'll find this edge on the right, then convert it to a NURBS curve. Find the center point. Then snap the right side locator over. Note, we only snap the translation. Why? Because if we look at the model, we can see the left and right models were just duplicated. So their orientations should be exactly the same. We've already defined the orientation for the left side. There's no need to do it again for the right side. Of course, we can test it. If our model's left and right orientations are not exactly the same, then for this right side wiper, we'll repeat the operation from the left side. Duplicate two locators, find its vertex and up position, then just do another aim constraint. So now that we have the position and orientation for both controllers, we can actually create the controllers. Still using the rectangle shape, we'll duplicate one we created earlier, then show it. Rename and group it. This group is the 0 group. Then let's match it to the locator's position. Note, we must match both translation and rotation. Then we can start adjusting the controller's shape. Let's scale it up a bit first. Before we adjust, let's look at a problem. This is a problem we've run into before when doing the doors and opening the front hood. When we rotate to the right, we'll see rotate x is a negative value. When we're rotating in this direction here, we want it to be a positive value. So we need to do the same operation here. Rotate the 0 group's x-axis to the opposite direction. But the 0 group itself already has some values. So when we want to say rotate 180 degrees on the y-axis, it's very difficult. In this situation, how do we handle it? There's a very easy way. We can use the properties of parent relationship. We know that the attributes in the channel box are relative to the parent level. So if I create another group here, and this group's translation and rotation are identical to the 0 group, let's match it. Put the 0 group under this group. Now we'll see the 0 groups translate, rotate, and scale have all returned to default. Now it's very easy to rotate it 180 degrees. For example, I'll rotate the y-axis 180 degrees. Now look, when I rotate the controller again, it's become a positive value. Okay, so this way, we'll select the 0 group again. Press Shift plus P to unparent it from the group we just created. These changed values will automatically update in the channel box. This way, we've redefined the zero group's rotation, and the coordinate system has also changed. This way, when we rotate the x-axis, it's now a positive value. So next, let's continue adjusting the controller itself. We want the shape to match the model as closely as possible. I'll move it here. Note here, I've made a change to the transform nodes translation. Don't forget, at the end, we need to re-snap the pivot point. I think this is about right. Freeze transformations. Then select the controller itself. Select the zero group. In Modify, find Match Pivots. This way, the two transform positions are exactly the same. See, when I rotate the x-axis, it's a positive value. Next, let's duplicate it to make the right side. Since we just changed the zero group's rotation, when we snap it to the right side, we should only snap the translation. Of course, if our left and right wipers have slightly different orientations, then it's the same method as before. Create an empty group, put the zero group inside it, rotate 180 degrees, and then unparent it. This way, we can also redefine the right controller's orientation. But since mine are identical here, I'll just snap the translation. The rotation is exactly the same as the left. Now let's look at these two controllers. When I rotate, they are both positive values, and they both swing in the corresponding direction. The next steps are exactly the same as before. We select these two controllers, put them under the corresponding controller. And don't forget to set their colors. Same as before, left is blue, right is red. Create trans groups. We'll need them to control the corresponding models. Then select our corresponding controller. Then select the trans group we just created, parent constraint. Same operation for the right side. Then put these two groups under the corresponding trans group as well. And next is to put the wiper parts model group in as its child. This way, let's take a look. Looks okay. But here, we need to check one more thing. Because our model now has some shaders, the glass is transparent, so it's not easy to see if the model is intersecting with the glass. Here in Shading, click Use Default Material. This way, we eliminate all color distractions and check if there is any intersection. Let's take a look. We can see the left wiper looks fine. It's a little high, but that doesn't matter. It probably won't be noticeable. But this right one is already intersecting with the glass surface. This is something we need to fix. How do we fix it? There are actually many ways. We'll use a very simple method to fix it here. Let's switch to the Rotate tool. And let's look at it in Maya's actual rotation mode, Gimbal. We are currently rotating on the x-axis. We needed to simultaneously be able to rotate outwards a bit on the z-axis. This way we can fix its intersection. But it's very dangerous to rotate the z-axis directly now, because when we are in this position versus when we are in this position, the result the z-axis rotation produces is completely different. Only when it's vertical can the z-axis rotate in this direction to fix the intersection. What do we want? We want the z-axis to always be consistent with the wiper's rotation. So how do we do that? Why doesn't the z-axis direction change with the wiper's rotation right now? It's because the rotate order is XYZ. We know this order means X is at the bottom. So when we rotate the x-axis, the z and y-axis do not follow. Now if we change it here, let's change it to ZYX. This way, take a look. When we rotate the x-axis, the y and z-axis both follow. So now, no matter what angle we rotate to, I can just rotate the y-axis to fix the intersection. And continue rotating down. See, I can still use the y-axis to fix it. This way, this fix becomes very easy. So we're using zy-x on this side. Let's keep it consistent. The left side will also use zy-x. Then let's see at what angle we need to fix it. As we saw, our left wiper doesn't really need to be fixed. It's just the right wiper that needs to rotate outwards a tiny bit. About 1 degree of rotation is enough. So here is 89.7. Let's change it to 90 degrees. Let's see the left side is also 90 degrees. We obviously don't want the animator to have to fix intersections every time they rotate the controller. So let's try to connect the node to automate this. How do we do it? We select the controller, then in Windows open the node editor. Then create a remap value node. This is for the right wiper. Let's call it rotate y fix 0001. We'll use rotate x to drive it. We saw this range is 0 to 90 degrees. And the range we're modifying is 1 degree. So the output here is 0 to 1. So when we rotate to 90 degrees, the final effect is 1 degree. Then connect this 1 degree value back to rotate y. This way, let's check again. When we go back to 0 degrees, the y-axis has no value. But as we continue to rotate towards 90 degrees, the y-axis will produce a value. When we rotate past 90 degrees, it remains 1. This 1 degree will help us solve the intersection problem. The main thing we used here was changing the rotate order to make the y-axis follow the x-axis's changes to achieve this effect. Let's zero out the controller. Zero out the left one too. We don't need to fix the left one. And don't forget to clear the node editor. Close the node editor. Next, let's clean up the wiper controller. Here, we only need the animator to modify rotate x. So let's lock and hide all other attributes. This way, when we rotate it, we won't have this intersection problem. But the one inconvenient point now is when we want to animate the wipers. We have to select two controllers to adjust their animation. If we look at real-life wipers, wipers basically move together. So let's add a new controller here. And use this controller to drive both wiper controllers to move together. Let's do this together. First, let's hide the model. Let's create an arrow controller. Move it forward a bit. Then show the car again. Then switch back to perspective view. This controller will control the rotation of both wiper controllers. Let's rename it first. Add a 0 group. Then let's put it at this position on the windshield. Scale it up a bit. Rotate it an angle. Then freeze transformations. Then give it a color. Since it's in the center, we'll set it to yellow. Next, we need to use its translate X to drive the rotation of both wipers. But look here, when I move translate X, when I move from one end to the other, my value is very large. My value is over 110. For this kind of overall driver controller, we don't want it to have too large a value. Generally, it's either 0 to 1 or 0 to 10. So what do? This is that special situation we talked about before. We can change the 0 group scale. For example, let's change the 0 group scale to 10. Scale the controller down a bit, and then move it over again. Now look, when we set it to 10, it's already at the other end. So here, we can scale it appropriately again. For example, 11.5. This way, look, when we set it to 10, it's at this end. When it's 0, it's at the other end. This attribute value looks much smaller. We won't have a situation of using a value of 100 plus to control two wipers. Okay, now that we've set it, don't forget to freeze transformations, because we don't want the controller itself to have any scale values. So next, we're going to use this controller's translate X to control the rotate X of these two controllers. But we must be careful. We can't connect it directly to the rotate X of the two controllers. Why? Because we want to preserve these two controllers so the animator can still fine-tune these two wipers individually. What we want is an effect similar to the car body. Look, when I move the cog controller, the front controller and back controller follow. And when I move the front and back controllers, they can still affect the car body. We want to achieve a similar effect here, meaning the main controller will control the rotation of these two controllers, but at a level above them. Their own rotate X should still be left for the animator so they can fine-tune it. So let's see how to do this. We should remember, the controller controls the model via a constraint. The constraint itself acts in world space. So even if we don't use the controller itself, for example, if we rotate the parent 0 group, it can still control the model's rotation. Of course, the 0 group itself already has some values, so we can't connect directly to the 0 group. So what do? We can add a group between the 0 group and the controller. Let's call this group connect. It's specifically for attribute connection. This way, look, when I create this group itself is in the same coordinate system as the 0 group. Its translate, rotate, and scale are all at default values, the same as the controller. So if I rotate the x-axis now, we'll see it has a control effect. So we can use the main controller's translate X to connect to the rotate X of this new group we just created to achieve the driving effect. Let's do the same operation for the left controller. Select the main controller and these two groups. Then go into the node editor, add them all. Then create a mult double linear node. We'll just call it rotate. Then we'll use translate X to drive it. Then connect it to the corresponding group's rotate X. Then let's change this value. For example, let's change it to 2 for now. Then let's adjust it. Obviously 2 is not enough. Let's set translate X to 10. Then let's increase this value. Let's set it to 9. That would be 90 degrees. Let's take a look. It has this kind of effect. Now let's set the main controller's limit. We'll set it to 10 here. The other end is 0. This way, take a look. Now, if we want to give the animator more freedom to adjust the effect, what can we do? Right now we have a uniform value of 9. We could actually take this value, 9, and make it an attribute on both wiper controllers, and let the animator adjust it. Sometimes it might need to be 8, sometimes it might need to be 7, sometimes it might need to be 10. This can be further adjusted based on the shot. So let's do that. First, let's lock and hide all attributes on the main controller except translate X, because we don't need these. Next, let's create an attribute on each of the two controllers. Let's select both controllers. Then in Edit, find Add Attribute. Let's create an attribute here. Let's just call it weight. It's a float attribute. The minimum value is 0. We can set a maximum value. For example, let's set it to 18. That would be 180 degrees. Our default value here is 9, because 9 times 10 is 90 degrees. Then we click Add. After we test this later, we can adjust the limit again. So this way, we need to duplicate the multiply divide node. One for the left side, one for the right side. Then we need to take that weight attribute. This attribute is on our controller, so we need to add our controller. Find the weight attribute. Connect it to input 2. Same operation here. Then take the right mult double linear node and connect it to the right connect group. Okay, so let's check again. It's the same result. But when, for example, I change this to 3, let's check again. We'll see the left wiper rotates more and the right one rotates less. So let's test its limit. Basically, 10 should be the limit. Because when we go past 10, it will slide off the windshield. That clearly shouldn't happen. So we can select the attribute, find it in Edit Attribute, and here let's change the maximum to 10. Then select the other controller, change it to 10 as well. And here let's change both back to 9. This way, let's look at this effect. If we continue to check, we'll see here, when I drive it with the main controller, the intersection still happens. Why is that? It's actually very easy to understand. We should remember, when we were fixing it, we connected a remap value node. This node is driven by the controller's own x-axis rotation. We used an attribute connection. So no matter how the parent group rotates, it doesn't affect the controller's own x-axis value. Because the x-axis value hasn't changed, the rotate y connected via the remap value node also doesn't have any change in value. So here, to make both levels of rotation drive the final remap value node that fixes the intersection, what do? It's very simple. We just need to add the two rotate x values together. Let's see. Let's find the right controller and show its inputs. We know here the remap value node is connected to its rotate y. So the remap value node will definitely show up here. Then find the parent connect group. Then create an add double linear node. And call it add right front windshield wiper RY0001. So let's add the two rotate x values together. Then use it to drive the remap value node's input value. This way, let's check again. When I rotate it, there's no more intersection. Why? Because let's look at the current sum. The sum here is the controller's own rotate x value added to the parent connect group's rotate x value. The controller itself has no value, but the parent layer has a value of 87 something. So when connected to the remap value, it will drive that 0 to 1 fix on the y-axis. If we rotate the controller itself backwards, let's look again. This way, one value is negative 80 something, one value is positive 80 something. The two added together are basically 0. Let's look at the position. It's also returned to the default position. So the remap value here also has no value, and it won't drive the 0 to 1 fix effect. So this is the method we use to ensure both levels of the controller have a fixed effect on this intersection. Finally, let's clear this. Then close the node editor. Return the controllers to their default values. The main controller above, return it to default as well. Then take this parent controller and put it under the corresponding controller as its child. And with that, the wiper rigging is also done. There's a very important concept here that we haven't touched on much before. That is creating an extra group above the controller. And by controlling the parent group's movement, we can achieve a layered control effect on the final model. We can see here at the lowest level, we have controllers to individually control each wiper. And above them, there is a main controller to control the overall rotation effect of both. This concept is very commonly used in rigging. We often add multiple groups above a controller, and each group will be one control layer. By stacking several layers, we can achieve more complex rigging effects. We'll continue using this method throughout the rest of the rigging process. Okay, see you in the next video.